All right, so hopefully last night or sometime over the weekend you watched the video of the vocab. If you have not done that, it might be smart to hold off on this video and go back and watch that. It's a quick 10-minute video, follow along with those notes you were given, and then come back to this so that you at least have an idea of the words I'm using and all of that, okay? So a couple things. You guys will get a copy of this tomorrow. This is the new calendar. Couple things. This is Unit 3C PBT due. I decided to hold off a little bit before giving that to you. So don't worry about that when you get that. And then we have this flexible learning day on the 18th, so we will talk about what that's going to be. You guys are going to have a factoring packet to do, which is a typical PBT. We're just going to give you a little bit more time to do it. So we'll talk about that. You have a quiz on the 21st, and then this is going to span quite a bit. Your test isn't until March 7th, so it's a longer unit, and it's all focused around probability. Okay, so last year you guys in Math 1 did all the statistics where you had a lot of button pushing and you did bar graphs or whatever the case may be. And this is now taking statistics from the probability standpoint, so we will not be doing any statistics. We will be focusing on probability. Okay, so today we are just going to talk about events and subsets and sample space. We're going to talk a little bit more about outcomes, unions, the difference between and or, complements, all that. Okay, and we'll do this for 2 days. So when I'm back tomorrow, we'll kind of revisit a few things. So if you have questions, please make sure to make a note of them so you can get them asked tomorrow. This is the other thing you're going to get in class tomorrow. I have these laminated for you guys. They are for you to use throughout the semester. You'll be able to use them on quizzes and tests as long as they're not written on. I know not everybody is as familiar with the deck of cards as I am. I grew up in a family that played a lot of cards. So you guys are going to have that. And then it'll be color-coded so you know the difference. These are hearts, these are diamonds, these are clubs, these are spades, things like that. And then the other thing you're going to get is we're going to talk about a lot about rolling dice. And so this is 36 different outcomes depending on how you can roll 2 dice. So this will obviously be something you can use. Otherwise, that would be pretty hard to recreate every single time I asked a question about dice rolling. So you will get those tomorrow. So you have them tangibly in your hands and you can look at them. Okay. So these are the vocabulary notes that you went over. Sorry, I don't know what I just did. Ooh, I hope I didn't just screw up our lesson. I think we're good. Okay. You guys, these are the vocabulary notes that you guys went over in that video. So understanding all those different vocab words. And then obviously if you have a number 6 on the bottom, we know you watched it. Okay. So again, I'm going to have that standard deck of cards out all the time, especially for the dice sheet part of it. Okay, so let's just go over a few things to make sure we're good on vocab. This is given the events, answers number 2 and 3. That should say 1 through 3. Anyway, here, oh, I guess, never mind. When you have your events, you have event A, which means we're looking for a number divisible by 3, and we have event B, which is a number divisible by 6. So that's what we're going to be using for the warm-up. This says list the outcomes of perfect squares. So if this is our sample space, all of these numbers up here are perfect squares. Our outcomes, remember you need to have brackets, are going to be, let's see, perfect squares. 9 is the first one. 16 is 1. 25 is 1, and 36. So we have 4 perfect squares as a subset of our original sample space. Okay, so we have 9, 16, 25, and 36. Now, you guys, with this next part, this says list the outcomes of A or B, and then list the outcomes of A and B. Before I do either of those, you're going to see me doing a lot of labeling and marking and things like that. This says A, so I'm going to circle A in red. If you have colors, it might help you. Otherwise, come up with something in terms of markings. A means a number divisible by 3, so I'm going to go through and I'm going to circle anything that's divisible by 3. So that's 3, that's 6, that's 9, that is 21, 24, not 25, not 28, and 36. So all of those circled in red are part of our event A group. And then for B, we have anything that's divisible by 6, I'm going to underline in blue. So 6 is divisible by 6. 24 is divisible by 6. And 36 is divisible by 6. Okay, I think I got them all. All right. So here, this says list the outcomes of A or B. Okay, so if we have A or B, that means anything that has a red circle or a blue underline. Okay, so that would mean I am looking at 3, 6, 9, 21, 24, and 36. Or that's a weird 24, but you get it. For number 3, this says list the outcomes of A and B. So now, because of the and, I need them both to be happening. Okay, so this is both, because it's and. This is everything, because it's or. Okay, so if I want them both to be happening, that means A and B, I need a red circle and a blue underline. So the numbers that are happening both are 6, 24, and 36. So notice we got slightly smaller when it comes to the and. The or should typically have more, kind of depending, but most of the time it has more elements than the and. Okay, so if we look at example number 1, it says Kendra is playing a game with a standard 52 card deck. She wants her first draw to be a heart or an ace. Okay, so a heart or an ace. How many ways can Kendra draw a heart or an ace? So if you look at our standard deck, a heart is all of these guys right here. And then an ace is all of these guys right here. So the total number of cards that would happen, couple things, you guys, there's always 13 in every denomination, 13 hearts, 13 spades, 13 diamonds, 13 clubs, and then there are 4 of each. So 4 2s, 4 3s, 4 4s, etc. So this is 13 cards because there's 13 hearts, and then 14, 15, 16. So how many ways can she draw a heart or an ace? There's 16 ways. Notice, you guys, there was one card that's a heart and an ace, but we can't double count it because it's only one card. Okay. This says how many ways can Kendra draw a card that is neither a heart nor an ace. So that means she now wants anything in this realm because she wants that not to happen. Okay, we call that the complement. So if there are 52 decks or 52 cards in a deck and 16 ways that it can happen, then that means there are 36 ways that it can't happen. Okay. All right, if you look at example number 2, it says some students were asked what pets they have at home. The following table shows results of the survey with students identified by numbers. Okay. So a student is chosen from the group at random. Consider the following events. We always try in probability to make sure that we use pretty typical letters with like dog is D, so on and so forth. So D is dog, C is cat, H is hamster, B is bird, and F is fish. This says describe each of the following events by listing outcomes. Okay, so we're just going to look at the chart. So C means the student has a cat. So the students that have a cat are students. I'm going to make this a little smaller, guys, so we don't need to keep going back and forth. There we go. Okay. So our C people are 2, 7, 9, and 10. Okay, so those are the outcomes of event C. Now, event D and B, we need the students that have a dog and a bird. Okay, so student 2 has a dog but no bird, so he doesn't count. 4 has a dog, no bird, doesn't count. 7 has a dog and a bird, so 7 would go in here. And 10 has a dog, no bird. Okay, so it's really just 7. Now, the next one is H or F, so a hamster or a fish. So as long as they fall in one of those two categories, we can place them into our list. So a hamster or a fish, we have 5, student number 5. We have student number 6 because they have a fish. We have, that's it, just 5 and 6. Sweet. All right, so the next one is B, but then do you guys notice you have that line over it? That means not B, so it means people who do not have a bird. Okay, so the students that do have birds are 7 and 9, so it's everybody else. So 1, 2, 3, 4, 5, 6, 7 does, so 8, 9 does, and then 10. Okay. All right, the next one is D and C, but not that. So I always go and figure out who has a dog and a cat, and then take everybody else. So here, dog and cat people are 2, 7, and 10. Okay, so if I was asking for dog and cat, then that would be who we are listing in our outcomes, but I want everybody else other than that. So that means I am looking at students 1, 3, 4, 5, 6, 8, and 9. Okay, and then last but not least, let's get rid of this so we don't get confused. Perfect. D or C. Okay, so this means dog or a cat, so either or, so that's 2, that's 4, that's 7, that's 9, that's 10. Those are all the students that have a dog or a cat, but again, you have that bar across the top, so we want everybody else. So we are looking at 1, 3, 5, 6, and 8. Okay, so this is just going through and analyzing the different outcomes that you could have in each category. Now, we're going to go the opposite way, okay? Now, we are going to be given an event, and then based on the event that we are, or the outcomes of the event we're given, we need to write out what the event would be. So we're going the opposite way, okay? So this says a student is chosen from the group at random. We have, the table below shows a group of students in the extracurricular activities in which they participate. Okay, so we have chess club, debate club, band, German club. Okay, and this says list the sample space. You guys remember, sample space is all of the possible outcomes we could have. So our sample space is going to be, do they all start with a different letter? Oh, that's awesome. All right, so we're just going to go by letter. So A for Asher, R for Ray, E for Eva, M for Merida, Y for Isabel, B for Ben, and N for Nate. Okay, so our sample space is the 7 students that we're looking at. Okay, so this says describe the event of Eva and Nate. I'm going to use a lot of highlighting here so we can really pay attention, and then I'll erase and do it again. Okay, so Eva is here and Nate is here. So we want to decide what is unique about Eva and Nate. When you are looking at this, you guys, you need to be really careful. You can't just say, oh, chess club, right? Well, Eva's not in the chess club, and Ben is, and he's not included here. You couldn't say chess club or debate club, because then Isabel and Ben would be there. So we're looking for the uniqueness of it. What is special about these two? So if you look at this, these two are the only two that are in German club. So our event would be German club. Okay. All right. So now the next one, here we go, says describe the event of just Isabel, which I might be saying wrong, but we're going with it. Okay. So we have just her. So what's special about just her? Well, she is not in chess club, but there are a bunch of other people not in chess club. She is in debate club, so is Eva. She's in band, so is a couple other people. She's not in German club, but it looks like she is the only student that is in debate club and band. So that's what I'm going to go with. Okay. So she is in debate, and that's your upside down U band. Okay. If you went through and found the one or the students who are in both at the same time, she's the only one, making her unique to that situation. Okay. Now, for the next one, we have, let's see, Ben, Nate, and Eva. All right, we got to get rid of that highlight. So let's look at Ben, Nate, and Eva. Okay. So Ben, we have Nate, and Eva. Okay, so the more people you have, sometimes the harder it is to look. And you guys, when you're doing this, we're only ever going to be dealing with either one thing, so not something, or as up here, just German club, or two things. You can't say like, oh, chess club and debate club and band. You're not comparing three things. The most you'll ever have is two. So with that being said, we have Ben, Nate, and Eva. So let's see. They are all in, we have a debate club and a German club. We have a chess club, and a German club. So if you look, you guys, if you have these are the only ones that are in chess club, even though Eva's not, or German club. So if you use the word or, then you're covered. If you use the word and, it wouldn't work because Eva would be out or Ben would be out. But if you say, oh, okay, cool, these are the only ones that are in chess club or German club, then you're good. Okay. All right, the next one is Ray, Eva, Ben, and Nate. So, same people, but we're going to add Ray in there. Okay. So, if you look, Ray's not involved in anything. Okay. So, sometimes it's looking at what they're not involved in. So, like here, Ray and Eva are not in chess, but Ben and Nate are, so it's kind of hard. There's nothing unique about two, but if you look, everybody else is in band and they are not. So we are going to say that this is not band. Okay. You guys, these aren't the only things. I have had situations where, just depending on how people look at it, you can have multiple events given your outcomes. You know, if I give you Ray, Eva, Ben, and 8, you might look at it a different way. You just need to make sure that it's a true statement, right? You wouldn't want to say here, like, not, I don't know. Let's say Eva wasn't in debate club. You couldn't say not debate club because Merida and Asher are also not in debate club. So it needs to be absolutely unique. So the one thing I do when I'm doing these is once I decide what the event would be, I go back and pretend I don't know what the outcomes are, and I highlight the events and make sure that the outcomes match what I was given. Okay. All right. For this next one, same idea, but we're going to add in Venn diagrams. So you guys have probably seen Venn diagrams a couple different ways. And they're going to be the same. If you haven't, we will refresh our memory. So this is Hector has entered the following names in the contact list of his new cell phone: Alicia, Brisa, Steve, Don, and Ellis. He chooses one of the names at random to call. Consider the following events. B, the name begins with a vowel, and E, the name ends with a vowel. So again, you guys, before I even do anything with this, I'm going to go through. If it begins with a vowel, I'm going to circle it in this purple. So remember, vowels are A, E, I, O, U. So Alicia starts with a vowel, and so does Ellis. Don't forget him. And then E ends with a vowel. Alicia ends with a vowel. Brisa Steve, not Don, not Ellis. All right. So now you just have half the thinking taken away. Okay. You don't need to go back and keep revisiting which one's B, which one's E. This says draw a Venn diagram to show the sample space. Okay. So you guys, when you draw a Venn diagram, you need to draw a rectangle that represents your sample space. And then again, you have your two circles that overlap. This we'll call event B. This will be event E. So remember, this is everything that is just B. This is everything that's just E, but the middle is the and. Okay, so that's the overlap. And then the outside is where they don't fall into B or E. Okay, so it says draw a Venn diagram to show the sample space and the events B and E. All right, that means we need to put everything into a category. So I'm just going to go through. Alicia is both, so she's going to go in the middle. Okay. Brisa is just E, so she goes here, as is Steve. Don does not fit in either category, so he needs to go outside the circles in the rectangle. And Ellis is just B, so he goes over here. Okay. So now we're going to use this Venn diagram. This is just another way to display information. We are going to use this Venn diagram in order to, I'm going to lock this because I'm going to do some highlighting, in order to list outcomes. So we already listed outcomes from a table. This is the same way, but from a Venn diagram. Okay. So here it says, describe each of the following events by listing the outcomes. B. Okay. So you guys, a lot of people look at B and say, oh, it's Ellis. But B is the entire circle. This all falls into B. So anything that you circled in purple up here, so that means that would be Alicia and Ellis. Okay, don't forget about Alicia. A lot of people leave her out because she's not part of just B on the Venn diagram, but she is in B. Same thing with E. Okay, E is this whole circle right here. It's anything that you underlined in purple. So that is going to be Alicia, Brisa, and Steve. Okay. All right, so now, let's get rid of that. We have B and E. So and means we want them both to be happening. So that's just Alicia. Okay, the and is the overlap right here. Okay. Then B or E. So B or E means anybody who's falling in either circle. In this case, the way we did it, anybody that has a circle or an underline. So basically it's everyone except Don. So we have Ellis, we have Alicia, we have Brisa, and Steve. Okay. Awesome. Okay, and then not B. Okay, so you guys, we already did B. Use that to your advantage. If B is Alicia and Ellis, that means not B is everyone else. So not B would be Brisa, Steve, and Don. Last but not least, B or E. Okay, so B or E, we already did over here. That's Ellis, Alicia, Brisa, and Steve. We want that. So basically, who doesn't fit into either circle, and that is Donnie Boy. Cool? All right. So, last but not least, just kidding, we have two more. An experiment consists of tossing a coin 3 times. Consider the following events. Okay, before I do anything, you guys, you're going to see this so much, and it's going to help you so much to set up a tree diagram, okay? So this says, consider the following events, and you're given 6 events. A says, list a sample space. Before I even think about events, I need to know what I'm looking at. So let's think about this. The very first toss, you could get heads or you could get tails, okay? So this is the first toss. We're tossing it 3 times. Well, from there, our second toss could be heads or tails. Well, if I get heads on the first toss, the second toss could be heads or tails. It's not going to change. If I get tails on the first toss, it could be heads or tails. So these are my options for my second toss. For my third toss, I could go heads, heads, and then I could still get heads or tails. I could go heads, tails, still get heads or tails. Same thing, heads or tails, heads or tails. So that means these are all the different ways this could happen between the 3 tosses. So these are my outcomes for the first toss. No matter what, each of those outcomes has 2 more outcomes, and then each of those 4 outcomes has 2 more outcomes. So what that means is total we have 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Okay, so if you look at this, the sample space is everything that could happen. So first, we could have heads, heads, and then heads. So H, H, H. We could have heads, heads, but then get tails. So I'm literally just going through each scenario. We could get heads and then tails and then heads. We could get heads, tails, and then tails. So that's all the different ways. If you get heads first, that could happen. Okay. Then you have the other side, because you could get tails first. If you get tails first, you could get tails, then heads, then heads. Okay, you could get tails, then heads, then tails. You could get tails, tails, heads, or tails, tails, tails. So you have 4 more options here, you guys. So I'm just working my way down each of the paths. So tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. And you guys, you're going to see me make that a lot over the next couple days. Now, I'm going to lock all this too. Okay, so this says, express event E in terms of other events. Well, event E is, let's see, do we have enough colors here? Okay, let's do this. A is the first tosses heads. So that's here, 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 or here. Those are all first toss heads. B is the second tosses heads. So that's this, this, nope, nope. Yes, the second tosses heads. Yes, the second tosses heads. C, I'm going to use blue. There are 2 consecutive heads. That means there's 2 heads in a row. So 2 heads in a row, 2 heads in a row. Nope, nope. 2 heads in a row. That's it. Let's see. I need to use a different color. D, I'm going to put a yellow star by it. There are 2 consecutive tails. No, 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 yes. No, no, yes, yes. And then I'll do an X in purple. The first toss is heads and the second toss is heads. So first toss, second toss, first toss, second toss. No, no. And then the rest of the first toss is tails, so that doesn't count. And then last but not least, I'll just put a purple, or good job coloring, sorry, orange. There are neither 2 consecutive heads nor 2 consecutive tails, so you cannot have 2 in a row of anything. So this would be okay. This would be okay. And that's it. All right, so now we have everything. This says express event E in terms of other events. So our sample space for event E is these 2, the first 2. Okay, so this is saying the first toss is heads and the second toss is heads. So what do we need to happen at the same time in order for that to be the same sample space? So if you look, A is the first toss is heads, B the second toss is heads. So we would need A and B to happen together. So basically if you look, we would want a red circle and a green underline at the same time. The only 2 of our 8 that have a red circle and a green underline are the first 2, so our sample spaces match. Okay. Part C says express event F in terms of other events. So we want to figure out what would get us just the 2 orange circles. Okay. So that is, there are neither 2 consecutive heads nor 2 consecutive tails. Okay, so if we did not C, because then we don't want two consecutive heads, and not D, so not two consecutive tails. So anything with a blue or a yellow. This has blue, this has blue, this is yellow, this is blue, this is yellow, this is yellow, that would work. So basically, I'm thinking of the complement. So I would want, what did we say, C and D? So C or D, but not that. Because then this has C in it, that's gone. This has C in it, that's gone. This has D in it, that's gone. This is C in it, gone, gone, gone. So then you're left with the sample space you want. Okay? And we'll keep practicing that because sometimes that is a little bit hard to wrap your mind around. Last but not least, it says an experiment consists of rolling a pair of dice. Okay, so you have that right down at the bottom. If you need to use this tonight on your homework, please feel free. Just make sure if you're going to mark this up, it might be helpful to do it with a pencil. This says an experiment consists of rolling a pair of dice. How many ways can you roll a pair of dice so that the product of the two numbers rolled is less than their sum? All right, so we are looking for all of the different ways that the product is less than the sum. So the product is less than the sum here. The product is less than the sum here, here, here. So you'll notice there's a pattern. Anything with a 1, the product is less than the sum. We hit 2, 2, the product and the sum are the same. Then the product is bigger than the sum. So those are all out. Anything with a 1, the product is less than the sum. Then bigger, 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 bigger. So you're just going through. This has a 1. So basically you're going to see patterns. You should start looking for patterns as you do this. Anything with a 1 has a product that is less than the sum. So how many ways? 1, 2, let's see, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ways. Okay. Okay, so now the last one, we're almost done. I know this is a long video, sorry. Probability is a lot of talking. The last one says, how many ways can you roll the pair of dice so that the sum is odd? So now we're ignoring the product altogether. We just want an odd sum. So that's there, there, there. Anywhere that there is an odd sum, you want to check. Oh, 5, 7, 9. And then 7, 9, 11, 7, 8, 9. No, hello. Guys, still working on my numbers, apparently. 8 is what you would call an even number. Sorry about that. Someday I'll learn math. 9 and 11. Okay, cool. So it's exactly half, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18 ways. So that is your answer. Couple things that you're going to want to start paying attention to. There are always 36 outcomes when you're rolling dice. Doubles only count once because they're not distinguishable. So you'll see like 1, 2, and 2, 1, but you'll only see 1, 1 once. Okay, so work on your homework tonight. Obviously, come in and see me with questions. You guys, we're doing the exact same thing tomorrow to make sure that we are all good to go because this is the basis of the entire unit. So if you have questions on the homework, please ask. I'm going to update the answer key, so make sure to check your work as you go or when you're done.